The next speaker is Michael D. from the Laboratory for Ecological Research at Oxford University of Oxford. And he will be speaking about radiocarbon-based chronology for Egypt over the periods relevant to the Exodus tradition.
Well, hello everybody. I'm going to talk about radiocarbon dating of the Eastern Mediterranean. That's a bit better. My two co-authors are two professors that work in the same department as I do at Oxford. I'd just like to make an observation before I start. First of all, thanks very much for the invite, Tom. I've enjoyed the conference very much. And thanks, Dina, as well, for her help in locating my talk as well that got lost this morning. But I just want to make the observation that I am a scientist and we make measurements. Most everybody else in this room, well, not actually the more recent speakers, but most of the people I've heard at this conference are involved in interpretation of either texts or documents or of archaeological remains. I'm more someone who produces primary data. I make measurements, and I think that's something important to bear in mind. So quickly, I'm going to have, 113, that was supposed to be 123. A refresher of radiocarbon dating for those who may not know much about the technique. And then I'm going to talk about radiocarbon chronology of the New Kingdom, and then get into some of the radiocarbon evidence relevant to the Exodus tradition. Okay, I don't know quite how quickly to summarize radiocarbon, but in effect we have radiocarbon, which is an isotope of carbon present in the atmosphere, naturally occurring, carbon-14, and that is taken up into the biosphere by photosynthesis, so you have a certain proportion of radiocarbon in living material. That is constantly replenished, and there's a sort of equilibrium between living things and their environment. When the organism dies, that replenishment from the environment ceases to carry on, and the concentration of radiocarbon in the living tissue, or in the dead tissue, dies away exponentially in accordance with the first order rate law. Now, all we need to do in order to make a measurement, make an estimate of the age of a sample, is determine really the radiocarbon ratio in the tissue that we find. That's a bit of an oversimplification, but I don't want to go into too much of the detail because I've got to cover quite a lot today. One of the key issues with radiocarbon dating is making sure we have the right starting concentration, the right concentration of radiocarbon in the atmosphere at the time the organism was living. And the way we do that is we basically measure the radiocarbon concentration of tree rings going back through time, because obviously you can count the tree rings, you know what year they came from. And in the bottom there you can see I've got actually how we convert a ratio, a radiocarbon ratio, to an absolute date here on the horizontal timescale against this tree ring generated curve. Beneath the, well, let me just first show all the sorts of things that we're able to radiocarbon date. There's some examples there that we've been involved with in Egypt. Essentially, a radiocarbon date is not an individual date in itself. It is a probability density function across time. And here are sort of schematics of what an individual radiocarbon date would look like. And what one actually does find is that this year here would be more probable in this case than this year. But we don't like to look at radiocarbon dates in that way. We summarize them by saying the highest probability range is this whole range here. All of those calendar dates at 95% probability in this case are included in our estimate, in our date generated from this particular sample. So once we've got these dates like this, say A, B, and C, it is now almost customary to apply a statistical technique called Bayesian statistical modeling, and it's not something particularly unique or to our field at all. In fact, a lot of scientists believe that at the moment we're living through the Bayesian revolution. It's involved in genetics, in medical trials, in marketing, climatology, all sorts of things. It's just another statistical paradigm. And what it allows us to do is take raw data like this and essentially refine the probabilities associated with each date. And we can do that by bringing in information from other fields. And here we might know, for example, that A, B, and C lie in stratigraphic order. And so then you put this into the computer program and you're able to get refined dates for each of those particular samples. That's how it works. So moving on. That basic technique, well, I'm going to go into a little bit more of it now, is how we managed to produce a radiocarbon-based scientific chronology for the New Kingdom of Egypt. We published a few years ago with my then PhD supervisor, Christopher Bronk-Ramsey. And I've recently updated this, really, included some, well, not so much new information, some new historical chronologies, really. I'll get to that just now, for a publication we've just brought out this year. So these were all actual samples, radiocarbon dates from when I did my PhD on this particular project. And this is kind of how it works. We knew archaeologically where all of these samples came from. We essentially got them from museum collections. So every so often you tend to get one that's a complete outlier and doesn't fit with where really one would expect it to. But the key thing here is we have a bunch of dates for each of these different kings' reigns, but what we also know is the order in which these kings ruled, and that's established from the archaeology. So all we need to do is put that into the computer program, and it will produce not only revised estimates for each of these samples, it can generate estimates for the time at the end of one reign and the start of the next. And we take that probability density function to represent or to include the accession date of the incoming king, because it's got to be after the time period of the king before and just leading into the reign of the next king. So we say that that probability function incorporates in time the accession of that king. Now, what we're able to do is even refine these probability density functions a little bit further by including various historical estimates of the likely lengths of the different kings' reigns. And let me get to that now. What I mean by that is this. As I think probably most people will know, there's not one historical chronology for the New Kingdom. Different scholars recognize different lengths of each king's reign. So what we can do is take our radiocarbon dates, take our modeled dates, and actually at the same time, during the calculation, feed in best, most probable estimates for the lengths of each king's reign from these different scholars here. We've got a longer one that was published in the Oxford History of Ancient Egypt, and then a middle one from Kenneth Kitchen, and a shorter one that's essentially Rolf Krauss. So in the end, after all these calculations are done, you have a radiocarbon-generated absolute chronology for the position of the New Kingdom. The position of that chronology could really be anywhere in time. If, for example, one didn't believe a word of radiocarbon dating, it could be yesterday, it could be 10,000 years ago. I think I already forwarded that on. There's the one that's generated from the longer chronology. I've got a couple of dates there highlighted because these are things people might recognize. These are the accession dates related to these particular pharaohs that also have, in some way, some connection with the Exodus. And I've just tried to put the median estimate here that we get from our model based solely on the radiocarbon dates, using the long chronology, using the kitchen chronology, and the short chronology. And essentially, as you can see, I think they stay in the same place, really. Now, these ranges here, because of all this information we're able to bring to bear on them, are very refined indeed. This is probably the most precise radiocarbon chronology produced. The 95% ranges are as short as 20 years. Now, how accurate is this then against the existing historical chronologies for the New Kingdom? Well, now I can overlay the results with where the historians would tend to place these particular accession dates. Some of the lines that I've got there are a little bit fatter than others, and that's because there's a bit of dispute about where exactly those kings, when exactly those kings took power. Others are individual lines because all the scholars seem to agree exactly on the year that they took office. And as you can imagine, it then doesn't really matter which of our models you choose. The radiocarbon chronology is exactly the same as the historical chronology. I say exactly, I mean, our results may peak perhaps about 5 years earlier than what the historians would think, but by and large, there is no difference between the radiocarbon results for dynastic Egypt and those one would expect on historical grounds. Now, what can radiocarbon dating bring then to the Exodus tradition? Clearly, we need to have physical remains before we can do anything. Even with modeling techniques, unlike the situation where we have a political chronology where we can model the lengths of individual reigns, at any given site, even if the stratigraphy is really good and really well established, you're not really going to be able to get radiocarbon dates that are more precise than 50 years at 95% probability. So that may be of consequence. But what we can look at is certain events documented in the Exodus tradition that we might be able to radiocarbon date. And one of them is the destruction of the cities, the Canaanite cities. And the other is the Thera eruption and the building of biblical Paramses. From what I understand, and I'm not an expert in this field, there are only 3 cities that might leave remains, datable remains from these particular events. The first one, I think, is still even disputed where AI is, so we can sort of discount that. There are people working on Tel Hatzor at the moment, radiocarbon dating it, and I'm not going to go into that one there now, even though there are 2 dates I know in the literature, and they seem to agree with each other, overlaying the sort of 14th and 13th centuries, which is actually in accord with various historical estimates for those events. But I don't know so much about those particular samples, and I don't think the second one is even yet published. But what I can do is talk about Jericho. Strangely enough, when I was asked to come and speak here, I was using the final destruction of Jericho 4 in a methodological paper that I'm writing with Chris Bronk-Ramsey at the moment, and we were just looking at different techniques of modelling, actually. And I just wanted to point out with this slide that in the original publication by Bruins and Vanderplicht, they have this date. We are doing a different average, but basically it's the same. And then there's 2 ways we're modelling. I'm just showing this to essentially show that no matter what modelling technique or you apply, this is the date you get. It's always the same. And just selecting 2 of those, averaged and modelled dates there in the grey at the bottom, I can compare them with our radiocarbon-generated estimates for the accessions of those kings that are connected with the Exodus. And it looks as though there's very little probability, perhaps a little bit, that perhaps the destruction of Jericho took place after the accession of Ahmose, but it's more likely that this particular destruction event took place in what we call the Second Intermediate Period. And then if one is to look at the literature, you discover that in 1957, Kathleen Kenyon had already estimated very accurately, using ceramic analysis, that the destruction of Jericho 4 was in 1580, which is again in perfect agreement with what we get from our radiocarbon analysis. And now we get to the debate over the eruption of Thira and work at Tel el-Dabba, the ancient town of Avaris. And let me just first summarize the scientific information about the dating of this event. First of all, radiocarbon dates have generated essentially the same date for this eruption since the 1970s. In year 2006, Manning collated a lot of those early dates and published them here in the same top paper, these two dates here. These samples all come from Turkey and Trianda on Rhodes, and the top one is from the household granary deposits of seed material, basically buried by the Minoan eruption. 28 samples. Since then, there have been a lot more. Now there's 43 samples. And as you can see, both the dates were the same. And that was published in Science, which I think most people would know is a very big deal. In the same year, coincidentally, a team in Denmark and in Austria located an olive branch inside the pyroclastic flow from the Thera eruption, from inside the lava, basically. And they radiocarbon dated that particular branch as to find out when it was destroyed, when it was killed. And because of the nature of the ring formations in the tree, you're able to apply specific modeling assumptions when you do that in radiocarbon dating. I won't go into that at the moment, but you're able to get very precise date for the burial of that branch, and there it is there, in the late 17th century, and in agreement with the two earlier papers. So at that point, the science debate is dead. Nobody is any more interested in discussing the date for the eruption of Thera. As we've already heard today, it was one of the largest volcanic eruptions in the Holocene, and it's probably now the best dated eruption as well in human history, well, prehistory. Since then, though, however, people have continued to find Thera and ash in various places, including Crete, and in here, in an island off the coast of Athens, really. And they have radiocarbon dated it and obviously published the results. I probably should have explained a bit more. This graph is showing as if you were looking down on one of those probability distributions. So this is the 95% range, and in the black, it's the 1 sigma, 68% range, the highest probability range. So if one summarizes all of those data, they're all very consistent. There's probably hundreds of radiocarbon dates that have gone into all those. And as I say, the science is essentially established and the date is around about there. The historians like to use this as a date for the for the eruption of Thera, and that's essentially something that's been received from ancient scholarship, really. And that's partly because there was... Well, hold on a moment, I'm getting there. This is partly because this is the first appearance of pumice in the strata at Tel Adaba in the late Tutmosid period, early Amenhotep II. However, there are other historians who would prefer to put it here, because the first pumice appears, for example, at Tel El Ejul in a certain stratigraphic layer. But then it seems to me, if there's 50 years between those two dates, why not just use the scientific date? Seems a little odd to me, but anyway, moving on. One of the reasons that people like to put the eruption of Thera much later on in the 16th and 15th centuries is because there is archaeological information to show that the Hyksos king Khayyan reigned before the eruption. This is because there's an artifact, a lid basically, found in a deposit on Crete that bears his name, and that deposit is buried by the Thera and ash. So Khayyan had to be before the eruption of Thera. Well, interestingly, even though for years of scholarship Khayyan was placed in the early sort of 16th century, very recently, 2012, relatively ironically, at the site of Tel El-Daba, a new seal for this particular king was found in a deeper layer than ever before, and it pushes this king's reign back to, even if you use the shortest possible historical chronology, before the eruption. And what did they say about that? One of them, the Cayenne ceilings, was found in an earlier second intermediate period context, strata E1, giving a terminus postgrim for this king in the early 15th dynasty. That was just last year. But what was more interesting even still was this established date for the Hyksos king was really challenged by Muller et al. In 2011, who found a series of seals with this king's name that push his reign back here in perfect agreement with all the scientific information around the dating of this particular event. And what did they say? They said 41 sealings were found, 9 of the sealings named Sobek-Hotep IV, who's of the Middle Kingdom of Egypt. These findings come from a quote-unquote secure and sealed archaeological context. This finding suggests that these two rulers reigned not too far apart from one another or were even contemporary. So it's sometimes hard to convince archaeologists of the pure scientific information. It's outside their field, it's not something they particularly want to know. But when you start to show that on archaeological grounds, in terms that make sense to them, that the radiocarbon dates are right, then it starts to make a difference in the field. So these are my conclusions. The radiocarbon dating agrees with the Egyptian historical chronology. There's basically no difference there for all of Egypt over the New Kingdom. It agrees with the the destruction of Jericho 4, whether or not it was related to the Exodus. There are consistent direct dates, radiocarbon dates, for the eruption of Thera from all over the entire eastern Mediterranean. But it disagrees with the chronology of Tel el-Dabba. Thank you very much.
Well, as the radiocarbon freak, I have the right to start, and also as one who participated in, I think, 15 or so publications, radiocarbon dating. I wish to start, I have 2 or 3 comments. The first one is that, Michael, you are right, of course, that you come from the measuring side of the equation, and we are, in a way, coming from the interpretation side. However, I think that there is, and I agree with you on much of it, there is certainly a certain space for interpretation in radiocarbon dating. And I can give 2 or 3, if you wish, later examples from what you have just shown. The second comment is that there are now many more radiocarbon dates for the end of the late bronze from the land of Canaan, from the southern Levant. You gave us Chatzor, rightly. Published dates we have already now from Tel Zayit, from Bet She'an, from Megiddo, and from Lachish. I may have forgotten. From Tel Safi, of course. How could I do this to you, Aaron? So, published? Radiocarbon. Okay, fine. So I missed something too. Right. And so this is a comment about the data available. And finally, a very short comment. In parallel to what you published in Science, we are now publishing a very thorough, and this is as an answer to a very thorough challenge by Tom Levy a few years ago, that one site should give us also a proper Bayesian model, the whole stratigraphy. So at Megiddo, we now have for a period of time, let's say between the end of the Middle Bronze and the end of the Iron 2A, approximately, 700 years. We have 11 layers, well stratified, we believe, with about over 200 determinations, and which is big. It's a big collection of data. This includes 6 layers for the late Bronze Age, beginning in the transitional Middle Bronze, Late Bronze 1, and continuing to the end of the Late Bronze 3, 6 layers. And this is the first time that a Bayesian model for the entire Late Bronze Age is going to be published. It goes very well with what you have shown, but I mean, it comes now also from the side of archaeology, because we are in a very good control over the relative chronology. At Megiddo, that is to say late bronze 1, late bronze 2A, late bronze 2B, 2 phases, late bronze 3, and so on and so forth. Aaron.
Paper, you presented data and methods of collecting data. As soon as you started dealing with the 3 sites which supposedly were destroyed by Jericho, that's interpretation. I think you have to go from, at some point, from the data to start interpreting the thing. So I think that's one issue. The other thing is, as far as the low and high dating of Thira, I think already in the 70s, when the early dating was suggested, a whole group of historically oriented scholars jumped on the bandwagon and felt very comfortable with it. It's as if only the scientists support the early dating. We have quite a few people who feel very, very comfortable with this, and in fact find that it's even much better than the later dating.
Can I really just comment? I think it's pretty plain. I was expecting other people to be in the audience and take a fairly negative view of what I was going to pitch in the way that they have done for many years. So I felt I had to be quite staunch in what I had to say, because this has gone on too long. I don't disagree that there are a lot of archaeologists who have accepted this for decades. But to keep coming to conferences and having to defend what is already done, really, from the scientific side is just... Anyway, but yes, I understand there are a lot of people who accepted it many years ago. And along the same lines, yes, I totally agree. I wanted to, again, for the same sorts of reasons, make it clear that I myself am someone who's involved in the measurement. Generally speaking, those little interpretations I added on in the end are from other Egyptologists, and well, I'm not an Egyptologist, from Egyptologists and archaeologists who have told me what to say. I just wanted to make it clear that it's not actually my specialty, rather than, yeah.
And this is very good that you are involved in the measurement, because Aaron and I would preach that the radiocarbon people should be working with us and deal with all problems of context and so on and so forth. Still, it's really a pity that Professor Bitak is not here, because it could have been interesting to get the other side take on these dates. Yes, Bill?
I'm sorry Manfred's not here, because he and I and many others have confronted each other about this. His chronology is about 100 years lower than our chronology for the southern Levant. And most of us feel that this, sides with our views. But Manfred simply denies it. I just wanted to point out that one of the firm pegs is here, the Cypriot white slip 1 ware is found already. That would normally have been dated not before around 1500. Now we have to raise the date by 100 years. That affects the chronology of Cyprus, and in turn affects the chronology of the southern land. And I think it simply supports, I won't say the high chronology, the conventional chronology. But Manfred resists this. I'm sorry he's not here to defend himself. He's quite capable.
I wish to take the side of, not the side of Manfred Bitak, but to defend him on one thing. Regarding the chronology of Tel Daba and the Middle Bronze, of course, there is a major problem regarding the end of the Middle Bronze, the eruption of Thera, and so on and so forth. However, I think that the data that we are getting more and more, including from radiocarbon dating from the Levant regarding the beginning of the Middle Bronze, there Manfred Bitak was right, I think.
I don't know so much about the Middle Bronze Age of the Levant. I know there's other major radiocarbon studies going on as well. At the end of my talk there about the dating of Haiyan, the lift there necessary for the work being done at Edfu is about 100 years. And that's kind of what I was trying to get across, was that there are archaeological examples now where archaeologists themselves want to move the ceramic chronology, basically, of Daba up 100 years. It's not just radiocarbon.
Can somebody Can one of you summarize Manfred's position for the group?
Well, so basically, he would like some of the later phases at Daba to be 100 years lower. Based on ceramic analysis and essentially the eruption of Thera, and when Thera is first evident at Daba. The other gentleman here, we might know a bit of, you were talking last night about, I'm not 100%, Thomas, yeah.
I would like just to throw into this. It's really a pity that Manfred is not here, because I mean he should have been given the chance to react to this. But I can just say that there is also a set of radiocarbon dates from measured at the University of Vienna, but by Walter Kuchera.
I'm on that paper.
Yeah. So and they are basically in line with your dates, the dates from Teledaba itself. So there is a major problem here, and we are not going to resolve it today. Thomas, you want to?
Just Thomas Schneider. I just want to say I'm fully in agree with the new data about Kayan and also the findings of Nadine Möller at EDFO. I think it fits very well with the evidence. I think Manfred's difficulty is that he has pumice that he has found in specific Teledaba layers, and he simply thinks the pumice could not have basically been intrusive to these layers in a different way other than directly after the eruption. So that is something that an archaeologist would have to deal with, and to see how the presence of pumice Teledaba can be explained in a way that would suit the new chronology.
As far as I understand, and I think that Aaron probably knows better than me on this issue, I think Manfred comes, if I may say, stand here for him, he comes also from a perspective of the pottery, late Minoan pottery. You want to add something to this?
It all ties into, Aaron Mayer, ties into a much complex understanding both of the dynastic chronology, the pottery in Egypt and in Levant, scarab seriation, etc. And I think his understanding of the Thira explosion, the date, it just goes with that. But just to point out how complex the issue is, you pointed out, for example, the more or less agreement on the the late 17th century dating for the end of Jericho, right? Somewhere 1600 something for the destruction of Jericho.
I think beginning of the 16th century. I think,
yeah. Radiocarbon dates did this anyway. So,
yeah.
1580. That's right. Excuse me.
Yeah.
1580. Now, one of the problems with that is in the latest series of Middle Bronze Age tombs at Jericho, which are then abandoned. There's now recently understood that there's a scarab of Thutmose III, which according to your chronology is at least 50, if not 80 years later. So what it means, I'm not questioning your chronology. I'm just saying that even an issue such as the end of a site and the end of a period is much more complex than just saying there we have the date and that's the end of it.
I won't whip back to the slide now, but that 1580 date is a ceramics date. That's not our date. Our radiocarbon date was over 100 years there, because we have very little information with which to constrain it. I can't remember the overall 95% range, but it was most of the 16th century, for example, perhaps even into the 15th, almost Thutmoside period.
Thank you very much, Michael.